All right, let's check your assignment. Make sure you understood how to compute these t-scores. So here we have this critical value for 90% confidence interval. See, so that's going to have the both with the 90% in the middle, the positive and the negative. Okay, so there's how we put that in the calculator. And then here's for the 98% confidence interval, 98% in the middle, puts 1% of each tail, and they gave me a degrees of freedom of 88. Next, we had this find the p-value for t is greater than 2.09. So that was asking for a probability. So that's the TCDF. From that t-score to 99, or you could do 999, whichever, just infinity, and 4 degrees of freedom. And so then that was that area. That's how much is in that tail. All right, the p-value less than negative 1.34 is that lower tail's worth of area. And this time it gave you a sample size of 36. So the degrees of freedom were 35. See, so you're always paying attention to if they give you a sample size or if they give you the degrees of freedom. All right, now here it's a two-tailed test. So here we have this sample yields a t-score of 235. So then that puts me 235 out on both sides. So then I need to find one p-value and then add it to the other one. Or, so you could either just do this one, 235 to infinity, and negative infinity to negative 2.35 and add those together. You could also go like this, see how much is in the middle. So I went from negative 2.35 to positive, and that was how much is in the middle. And then once you know what's in the middle, subtract it from 100% to see what's in the tails. Okay, so either adding both tails together or subtracting out the middle. All right, so here we had an actual interval that you were making a 95% confidence interval. So the mu of C is the average carbon monoxide levels in Rochester. We did not have to do these conditions, assume they're meant. Okay, this is called a one sample T interval specifically for means because we have T distributions used when we talk about slopes also. So we're having to say for means. Okay. So here's kind of all the information. What do I need to make sure I'm including? So very minimal amount of things to include. You need to show, you have to identify a few things, okay? So I think this is a standard formula. So if you wrote these things here, you're okay with one exception. You would need to identify where this magic number 0.26 is coming from. It can't just come out of nowhere. So make sure you show, as a very minimum, that plus make sure you identify the degrees of freedom. Now, I had done it over here, so I was covered. But technically, a lot of times I like to do it right after when I write this here. Here's the interval I computed on the degrees of freedom 21 curve. Okay, so there is the minimum to include, and then of course the interval. Okay, all right, and so I am 95% confident that the true average carbon monoxide level in Rochester is between 4.56 parts per million and 5.64 parts per million. All right, this is a panic as well. So similar process. The average of the mu of t, I called it because this was about traveling time. So the average one-way travel time for all such college students, okay, make sure, this is a population inference. So you are inferring about this population. So all such college students, I don't know, are they talking about ones from a certain college or what? Assume these conditions for inference have been met because I was told that. All right, so we have a one sample T interval for means. Okay, and here's the same information again. All right, so again, bare minimum, this is needed, but you would need to indicate where this is coming from, okay? Because you cannot have numbers come out of the middle of nowhere. All right, which, do we need to say how you got that? I don't know. I don't think you would get counted off. But you must include the DF. So I have it over here on the side, but you need to make sure that you have got that somewhere prevalent so that person knows how you computed that. I am 95% confident that the true average one-way travel time for all such college students is between 16 and a half and 22.3 minutes. Okay? All right, and now a test. So a phantoms. So because we want to know if we have sufficient evidence about a claim. That's a hypothesis test, a phantoms. So mu of h is the average lifetime hours for all this type of light bulb. All right, so it's hypothesized. The null hypothesis is that it's 1520, but we are investigating if it is less than 1520. Assume all conditions for inference have been met. So it is a one sample t test for means. All right, what must be included here? Well, here's what it needs to be. We need to show. Definitely, this has to be here in addition to how you got that standard deviation, okay? So these two things are required for minimum, with saying then that the degrees of freedom equals 39, so make sure that that is located somewhere. And then you don't have to have this calculator speak, so not necessarily needed, but of course then you've got your probability. It just feels naked if you don't have something like this written or somewhere saying what the probability is. So O is obtain a p-value and compare it to alpha. We were not given a significance level there, so we had an alpha of 0.05. So here's my p-value, which is greater than alpha. So I fail to reject HO. Since the p-value is greater than alpha, I fail to reject HO. There is no evidence that the average lifetime of all such light bulbs is less than 1520. Okay, so my sample could have been just because of sampling variability. It wasn't Freaky Friday low. Okay, it wasn't way, way low. All right, so now let's talk about the AP testers trio. So here, remember this wording bias that could cause something to be not representative of the true population amount? Well, so if somebody says, hey, given humanity's great tradition of exploration, should we fund space flights? Well, so make sure you read what they're wondering about. Would this sample results of the previous question give an overestimate or underestimate of the actual proportion of people who want to fund space flights? Well, this would make them want to fund space flights and continue humanity's great tradition. So this would lead more people to be saying yes. So this would be an overestimate of that proportion. That is probably the true population one. All right, the next one here. We've got adolescence is a time for teens to freely express themselves. Do you think high school students should be forced to wear uniforms? Okay, so that's going to make people say no. They should not be forced to wear uniforms. So let's see what they're asking here. Would this overestimate or underestimate the actual proportion of people who think that students should wear uniforms? That would make them want to say, no, they shouldn't wear uniforms. So this would probably underestimate the true proportion who say they want to wear uniforms. Given that 18-year-olds are old enough to vote and serve in the military, is it fair to set the drinking age at 21? Okay, so that's going to want me to say, no, good gosh, they can die for our country, so they should be able to drink. All right. So that's going to make me want to say it's not fair. Let me see how the question is worded, though. Will this overestimate or underestimate the actual proportion of the population who think it is fair to set the drinking age at 21? So this is going to make people say, no, it's not fair. So it's going to underestimate the proportion who think it's fair. Okay. All right. And then here, this is just kind of a matching thing. Remember, convenience. If it's convenience, you're kind of just getting at one particular area. Um, it wasn't, getting the people in a particular neighborhood, might not be representative of all of Aledo. So that's under coverage. Face-to-face interviewing, you got lots of different kind of response bias you could have. Uh, and of course, anytime people are volunteering and selecting or placing themselves in the survey voluntarily, then they feel passionate about the issue. So that may not be representative of all people. So the census of the large population, so that's difficult sometimes because it may be you may have too much of it not represented. So the non-response bias is sometimes associated and dangerous with that. Okay. So here are just the types of bias definition. So the first one was under coverage, and you can go back and read that. Second was non-response, too many refuse or don't answer. And then, of course, C is response and D is voluntary response. If I had put question 3 first, it might have actually helped you with question 2. All right, there's your little bit of AP review from Unit 1 on sampling and experimental design. Okay, I hope that covered you well on your first T distribution assignment.